Hello everyone, today is 20th of February 2019. This is my 9th episode about C++ type functions, modern C++ programming. In this episode, we will learn how type functions relieves you or me from the burden of implementing advanced data structure. More specifically, we will understand how C++ static array is useful, or how can you use C++ static array. We will also learn non-type template parameter and auto 3 dots as template parameter. I will call auto as non-type template parameter and auto 3 dots as variadic non-type template parameter. We will learn how to use these keywords in C++. Say, when we implement advanced algorithm, we have to concentrate on our algorithm, but if we have to have the burden of implementing advanced data structure, it will be quite challenging for us because we have to implement the data structure and we also have to concentrate on the algorithm. Our burden is double time heavy. So if we can relieve from the burden of implementing advanced data structure, then we can concentrate on the logic, on the algorithm itself. So if we can implement advanced data structure rather simply or easily using type function, we can concentrate on our logic, on our algorithm. This session continues from my previous video. Please click this link and download the source code from our previous video. When download is complete, show in folder. Please unzip it. Double click this folder, right click, copy, paste it to your working folder. Double click the folder. Here, create a folder, OA, non-type template parameter, like this. Then click this folder, copy folder path. On your command prompt, right click, properties, in starting field, Ctrl A, Ctrl V. Then click OK. In your Visual Studio Code, open folder, paste the folder path, / enter, select folder. Select non-type template parameter, click this button, PCH, then create one more file, PCH, CPP, then create one more file, non-type, CPP. In the PCH header file here, include talk play fun type util.h, and let's include one more, include type function tutorial, type liv. This is the file we created in our previous sessions. Click PCH CPP, include PCH.h. In non-type, click this file, include PCH, auto stream, talk play fun stream, auto nl stream, get console out, int main stream, hello static array, and non-type template nl in your command prompt, dir cd 08 Nontype Template Parameter. dir, we need to build PCH precompiled header first. cl at PCH local PCH CPP. Okay, we built PCH file, then cl at MSBC local non-type CPP. Okay, you should see this message successfully. Let's think about static array first. Template type T, size T n, void take static array. This function will take a static array as argument like this. T is type, n is size. But this is not good enough. We cannot pass array with this syntax. Instead, we have to bind like this, and this convert into reference. T reference n is a reference, L value reference to an array of type T with n elements. Okay, then we can print out string like this: talk, play, fun, get type name T n L. Type is passed as parameter. Void test static array. We create an array int. We initialize with 5 elements, 2, 3, 4, 5. Then we call take static array, array. We can print elements like this: string. We need parameter name, T array. I'm very sorry. Array like this. Okay, T is type and array is reference, n is element count. Okay, then we can print out array NL. We call this function okay. I hope you understand. Now build 9. I think I'm a little bit out of mind. I've been thinking something else while typing, so I made such stupid mistake. Let's build again. Okay, it seems to be working. Please examine this code. So we passed the array like this syntax. We defined a static array or one-dimensional array with 5 elements and passed to this function. Then the type int is the type of T and n is count 5. Then we can put it here like this: array. I will compile once again. m, like this. Okay. Now what about two-dimensional array? Okay, here T is type template parameter, N is non-type template parameter. Why N is called non-type? This is not type. Type is size. Size T is type. N is non-type. It makes sense. Now let's make another function. Template, type name, T, size T, N1, size T, N2. Okay, this time I will use auto. Auto, N1, auto, N2. Then void take static array T array N1 N2. This is two-dimensional array, two-dimensional static array, two-dimensional static array. Here T is type template parameter, N1 and N2 are non-type template parameter. So take static array is overloaded. Then I will copy. Then this is N1 and N2. I fixed it like this. Now let's call this function. Array 2, 5. Five, 4, 3, 2, 1. So we are passing take static array 2, two-dimensional static array. This time we are calling this function y is giggle. Okay. See? We haven't displayed. Now build once again. Okay. Please compare this code. Pause your video for a minute and examine this code. I think I need 10 minutes break. Okay, I had 10 minutes break. I'm trying to hold down my laptop. Sorry. I will be serious from now on. I'll be serious. Okay. When we create container, void simple tip for my audience. So we are creating, when we create a container, std vector, for example, int b 1, 2, 3, 4, 5, then we can display the container elements like this, b, nl. It is pretty boring. Okay, let's try it. I copied and pasted. Then I compile again. Okay, it displays like this. This is very boring. You have to type the long type name like this. Instead of doing this, create a function like this. Template type name T or type name types. Then std vector type make vector type first types args std vector. No, we don't need this. You can just do like this. Return std forward type first std forward types args like this. I need to concentrate like this. Then instead of doing this, we can do like this. Auto v1 make vector 1 2 3 4 5 6 7 8 9 10. Okay, then we can display stream v1 and L. Let's try once again. I will change it v1 v2 v1 v2 v1 then okay, it works. Now let's try with more advanced one like this. Auto v3 make vector Thomas Kim Sophie Turner Alice Kim. Okay, now let's print string v3 NL. Now let's build. Wow, it says constant character 11 constant character. So we have to fix this problem. I disabled this. First, let's try this function template type name T void print type arg stream talk play fun get type name T. I say type of T. Then type of arg talk play fun get type category arg and please note that this get type name and get type category are my own implementation. These are not standard library. Now try this function print type Thomas Kim If we run it, and type name T is constant character reference 11. Constant character reference 11. Constant character reference 11. Okay, so this make vector does not work. To resolve this, we need two things. We need to understand type decay. Template, type name T, size T, N, auto, decay, type T, array reference, and return array. I would say characters. Okay, decay array. I will change it like this, decay array. With this, we are trying here once again decay array. Now I modified like this. And see, it becomes constant character pointer. Decay array to pointer. With this information, we need to create some more type functions. This tutorial is how to make type functions. I will add here. Template, type name T, struct, container element SD. Using type T, using element type T. Then this is primary template class template. Then we are making specialization template, type name T, template, size T, and struct container element SD, constant character reference. I will say just N first. In this case, we are doing like this, using type constant character N, using element type. We are converting it into string class like this. And we need one more. This is non-reference case, non-reference. Then we are making reference case like this. This is reference. Then I need to here like this. Then we need to deal with wide character. Copied, paste. This is wide character T. It should be W string. Wide character T. It should be W string. Sorry. W character T. And W character T. Like this. We introduced 1, 2, 3, 4. Sadly, we need to introduce more. What about non-constant character type? Then copy, pasted like this. I will remove constant here. In case of character array, removed, 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 then remove, remove. I'm removing constant. Remove. I think there is a simpler way actually, but I will deal with that sometime later. So I removed all constant. Okay. Now with this template, type name T, using element, container element, container element T, type name. I copy this part T here. Watch this. We are using this like this. Okay, I modified this. I will also change it here. I will make it auto like this. Auto. Sorry. I will copy this. Copy. I will paste it for the time being. Then I will change it to auto. And if context pair std is array b. Okay, so here we have to remove std, remove reference t. We learned this function in our previous session. Here, type. Okay, then we actually don't need to remove like this. If it doesn't work, then we can fix. Okay, here using element T, container element T, type function tutorial. Okay, remove constant reference T. Here, type. I don't think I need this. I will just say remove reference or just type. I think this is good enough. Then using std vector element T, then container T. Then we do like this. Return container T. We have to convert it to pointer. Please note that we have to use this function decay. Where is the decay? We have to use this decay. Where's it gone? Decay. We defined here. Copy. I will put it here. Decay. Okay, we are using this. Copied. Then decay. First. Decay. Array. args. Okay. And this is array case. And it should work properly in this case. Now we enable it. Okay, we enabled it. Now, my God, it doesn't work. I think the problem is here. The problem comes from here. Then we will remove type function tutorial, remove constant reference. we remove reference. Then let's try again. Why is constant character reference? Sorry, we have to remove here. Type function tutorial, remove constant reference. Like this. From this type, we have to remove a constant reference. Now let's try again. Okay, it seems to be working. Yeah, it's beautiful. I will remove this part. Let's run it again. Yeah. Now let's think. Here we are passing constant character string. This is null terminated string. This works because this is null terminated string. This element becomes string, so it does not work because in some case this is not null terminated character array. So we have to fix like this. Element T std begin. What C begin? C begin std C end first. The reason we have to do this is that in some case this first is not null terminated string. Okay, and here element T std C begin std C end args. We have to fix like this because in some case this constant character string is not null terminated. It can be array. Also because we removed constant reference, so we don't need constant case. We removed constant and reference. So here we don't need constant and reference because we removed reference and constant. Also, we removed constant reference, so we can do like this. We don't need this. I remove these up to this point. I removed, so it becomes much shorter. Now let's try it. Okay, it works perfectly. But there is another problem. The problem is that in this case it can fail. Okay, let's try when it can fail. INTA 1. If we put it A, then it fails. Wow, it worked. How come? How come it worked? This is L value reference. Now double check. String type of talk play fun get type name type std and there. Now let's try it. Wow, it is int. Oh, I put it in wrong place, not here. We have to put it here. I put it in the wrong place. Here. Let's try it. Sure, it doesn't work. The reason it doesn't work comes from here, because it is reference type. So we have to use type function once again like this, using element t, type function tutorial, remove constant reference, then type like this. Then I have to modify like this. Let's try it. Okay, it should work. Perfect. No, this is not perfect. Watch carefully. Before comma, there is a blank space. Before comma, there is a blank space. Before closing curly brace, there is a blank space. Because the element type is string, string handles null terminating character. We have to remove the last element. So we are introducing another member, static context pair, bool is character array false. In this case, it should be true. And in this case, it should also be true. Then here we make another type function, template, type name t, context pair auto is character array b. Then we copy this, t is character array like this. Then using this, we copy static static assert is character array. Please note that we have to remove type function tutorial, remove constant reference t, type. Should be character array like this. This is to allow only character array. And here we need to check if it is null terminating character. So I will introduce once again static context pair size t array count. In this case, this is 0. I copy once again. In this case, it is n. Okay. I copy once again. Copied. And we can put it here again. Template, type name t, context pair auto array count b. We can copy this part and it should be array count. Instead of doing this, I will modify this part. Type function tutorial, remove reference constant reference t like this. I will remove at this part. I copy it once again. I paste it here. I will also modify it like this. Then we don't need this. Like this. And we don't need this because we added it. And another thing we need to consider is this. If context pair is character array type. No. Because this is character array at this point, it is already character array, so we need character count. Array count B. Array count B type. It should be greater than 0. Then it is possible. Here we are testing once again. If we need to add one more here. I will need one more using. I will remove this part. We don't need this. Like this. With this, element flat T. Here we are providing this like this. Type name. Please note that this is type using element flat type. With this, here we are testing like this. First, this is array, so array count. No, we will use auto last character first, array count B type. Please note that we have to -1 last character this means last character is null character. In this case, we have to provide type here. Type. Element flat type. Container type. Okay, it works. It means last character is null character. In this case, we can simply use like this: return container t decay array first, decay array args. Else I will change like this: size t, size like this, and size -1. This is last character. We will take reference, then I think it is fixed. It is fixed. Let's try it. Wow, this part is fixed. I have almost forgotten one thing. In C and C++, static array element count 0 is not allowed. What I mean is that int array 0, it does not compile. See? Cannot allocate array of constant size 0. This is not allowed in C and C++. So this part is not necessary. This part we don't need to check the array count. Okay, I fixed like this, and constant is safer, so I need to remove this curly brace like this. This is array case, and this is non-array case. Now let's build once again. I will enable this part. I build again. Okay, it works. In this case, make vector container type is hard-coded as std vector. In this case, make vector return type container class is hard-coded like this. In more advanced case, we will create one more function. I copied, pasted, and instead of make vector, we can say make container. And we provide like this: template, type name, cntr type. This is container type. Then we copy here. Instead of std vector, we can put container type here like this, and also at here. Okay, we modify the container type. sorry, I need class here like this. Using this, I will copy once again. I say simple tip for advanced tip. Advanced tip for my audience. Instead of doing this, I will delete this part. You can say make container. Container std vector. It works as before. Then here I will delete v1. Then I will use, let me see, we can actually use any type of container, I guess. Decay, std decay. Now I will call this function. Then we can define arbitrary container type. Now let's build. This is not make vector. Copy, paste, try again. Okay, now we are using decay. We are using once vector, once decay. I have a few more really important and useful container class, but this session becomes too long. In my next session, we will learn really useful and really important container type. Please subscribe to my YouTube channel. Thank you for watching.